Hello, everybody. Welcome to another show and tell. Thank you. Welcome to the Adafruit show and tell. I'm your host this evening. We're going to kick things off with John.
I love this. You're getting notes.
Yeah, I got to post it from my special guest who will
from
be
the producer.
From the producer
or something.
All right. So what is happening? What do you have for us tonight?
I'm just entertained by what's going on over there, honestly. So what's going on here is I'm continuing to work on a BLE scanner on the Clue, a Bluetooth scanner, which I just realized I want to call the Cluetooth scanner.
Yes, perfect name.
And it's there it is. It's a Clue in a case that I think you or Pedro designed a while ago when we were doing Clue cases.
I think Pedro did that one. Yeah,
just printed that. It's lovely. And what I've got going on, actually, you probably just saw it update itself, is every, I forget, 20 seconds or something, it just sniffs the air to see what BLE devices are advertising themselves. So you just see this long list. I've got, 12 devices here. It sorts them by signal strength, and we can find out more about them by clicking buttons. We can go through the list using the cap touch buttons down here. And we can also sort things when it starts to get out of hand, because after a while, actually here in my workshop, it's not too bad, but in my house, suddenly there's like 37 devices showing up on here. So it's helpful to be able to sort them. So if I hit the little 0 there, you can see these are ones that actually give up their name. A lot of Bluetooth devices don't. Mm-hmm. Here are known ones, which is devices that have had the same MAC address for a little while, and we've caught them on a few scans. Here are Apple devices. And so those, Apple is interesting because they don't want to, for good reason, for things to be tracked. So they rotate their MAC addresses pretty frequently. So a device can't really be targeted as this is that exact device, but they do have BLE services and other features that they say, hey, I have battery I can tell you about, and I have, if it's an Apple Watch, probably has some of like the heart rate kinds of things that you can connect to your Peloton bike or whatever. So in this case, if I take some AirPods here and probably start advertising, looking for like a phone or a computer to connect to. So the next time this does a little update, we'll probably see up on top, because they probably have the strongest strength. So there it just said AirPods just showed up. And I can click a button here and find out more about them, like the signal strength, the number of times it's seen them. This code, which I worked with Claude AI on, does guesses for things, because Apple doesn't say it's an iPod, but or an AirPod, but it guesses that based on some of the other services and things that it advertises. So this one's advertising AirPlay, and you'll see some devices say, hey, I have handoff and AirPlay, and then it'll go, oh, you're probably an Apple TV or something. And same sort of thing if I filter here. I think if I turn on my little Bluetooth calculator / number pad here, yeah, that just showed up as 8-bit DOE retro 18 new something or other. So we can click on that and find out a little more about that. So you can't really sniff, you can't alter things, you can't send. Right. There's a lot of security around BLE for good reason, but it is kind of interesting from the standpoint of understanding the things that are flying around in the air and near you. Could be for security reasons, could be for curiosity reasons, could be just to test if something actually has working battery in it. If you try to turn it on and it shows up here, well, that's a
that's
start.
a good one. Yeah, it's a good use case.
That's what I've been working on with my little.
Have you found have you found anything weird that you didn't expect to be around your area, or how?
Sorry, my AirPods picked up your voice and started broadcasting. Let's see if you're back on speaker. Funny. You are, yeah. Okay, they stole my audio.
That's funny. Yeah, that'll happen to me too. What was I saying? Oh, if there's anything like weird that showed up around your house that you had no idea had Bluetooth, like I don't know, a toothbrush or your radio or something.
The headphones started showing up. So even ones that were turned off but plugged in Bose headphones, like my wife and I both have kind of the same one, and so those have their whole ass name in them. which I'm sure if you turn this on an airplane, you're going to find out the name of half the people on that airplane, because everyone's devices often end up, putting your name in it if you're trying to distinguish from other people else. Also, there's one on here that we have these air pure, what do you call them? Like little fragrance dispenser kind of things. Pura is the brand. So you put little capsules in it and it heats them, and it's got an app, of course. We have 3 of those in the house, and they started showing up on here initially as Espressif ESP32. So I was like, oh, okay, that's what those are. And then I found its like manufacturer string online, or Claude did, and gave it a proper name. But I don't think we'll find one in here because I'm a little too far away from them. But this one, I was mystified about what it was. I think I just had to look up its name. It turns out one of my
like a
lights. Well, one of my like what's the brand on these ones? Nan light. I have a Nan light that I thought was off, but I guess when it's plugged in and turned off, it does still advertise Bluetooth, which makes sense because you can soft turn it on.
Yeah.
And then I'll also see things like generic looking names like dishwasher showed up, and it wasn't ours, and it had a kind of low signal strength. But when I clicked on it, it told me it was advertising as a Samsung as a manufacturer. And so I guess I now know what my neighbor's dishwasher brand is. So, it's kind of weird little,
it is weird,
yeah, creepy-ish, big brothery data shaping, figure out things from the stuff that's flying through the air. I think I have to reset it right now, or let it try a couple cycles. Sometimes it has a memory allocation and error right now, and it'll
too much Bluetooth. It's just so much
Bluetooth. Yeah, so much Bluetooth.
Wild. Cool. All right. Well, we're are you planning to show more about it on?
Yeah, I'll show a little more about this, and I've got another project in the works that I'll be, I think, finishing up, which is this little leverless hitbox style game control. Have you ever used these kinds of things? You seem like you'd be good at fight games since you're a finger drummer. Have you ever used these?
I have not. I've never heard of the term. Was it leverless?
Leverless or leverless. And the company who made them first was called Hitbox, so that name gets used generically a bit now. But I'll show a bit of that tomorrow. The thing that I really was amazed at is for stuff like Street Fighter, if you're doing a fireball, you're going right, down, left with your joystick, or left, right, down with your joystick, and then hitting a button. And I miss those a good bit, but with these, you're just kind of rolling your fingers across 3 buttons, and it actually is way more likely that you'll get that timing and and everything right, because you're not relying on this sort of rotation motion. So it also, these tend to put what ends up being jump in fight games as your thumb, because there's nothing worse than accidentally jumping up in the air in a fight game, because then you just get uppercut. Like, you're almost never, like, if you watch a good player, I'm not a good player, but if you watch good fight game players, no one jumping around. Everyone's like on the ground doing like, these crazy moves. And it's pretty rare to be jumping. So this makes it super unlikely you'll accidentally do it. And if you intend to do it, great. You're hitting your thumb on either hand. Actually, they kind of put them in the center between the 2 hands. So I don't think I'll become an advanced player with it, but I thought it would be fun to build one of these. And I can't remember how much I've talked about this in the past, but I did end up creating a board profile for the QT Py RP2040, which is what I have there on one of our little BFFs. Because GP2040 CE is this fantastic firmware that runs on Pico and KB2040 and a bunch of RP2040 based things. Didn't run on this QT Py, but QT Py is pretty good for this number of buttons, like 11 buttons. And so I created a little board profile that I'll try to submit to their GitHub, so that ends up as part of the boards that people can just download. So
nice.
Yeah.
Cool. All right. Well, I'll check you out tomorrow.
All right. Thanks, man.
Showing off. All right. Bye. Okay. Next up, we're going to take a look at what's Anne cooking. Hello.
Hello. For the last month or so, I've been trying to work here. We'll start with mine first.
Here we go.
These little Espressif came out with their little ESP claw, tiny companion or mini LLM or something. And it's generally been supported on more and more boards, just kind of like John was saying. We've got it running on the Adafruit Metro ESP32S3, and I'm trying to get it working on the Qualia that Adafruit has. Actually, Adafruit sells this ESpressif display. It works fine, but I had this one handy. So what it wants to do extended thinking is to be connected to Claude or OpenAI or some other cloud model, and then that does the really heavy thinking, whereas the local thinking is more like turn on this pin or what is the temperature. But I was having trouble connecting it to Claude, and I really didn't, for the amount of work that this is doing, I thought connecting it to internet model was kind of heavy. So previously I'd written a guide on how to set up a LLM on your home computer, and you can download different models, and they have pretty good processing power. So I just wrote a guide in Adafruit Playground for using the local model to talk to this and be kind of like the brains and not have to go to the internet. So right now it's kind of saying, oh, you know, I asked it, hello, how are you? And I'm doing great, thank you. Running smoothly, fully operational. And all this is not internet. It's all local to my home network. So, you know, there's no tokens per second. There's no, you know, configuration charges. It's all this little device talking to my the same computer I'm talking to you all with. So,
wow,
yeah. So it's kind of fun. I like the idea of small little personal devices. You know, maybe eventually I will, you know, kind of marry this with, you know, something like this for a companion robot or something.
Shoulder claw.
Yeah. I mean, you know, it won't be quite OpenClaw. I mean, OpenClaw takes like a Mac Mini or something, and I don't think I'm going to shove it into there, but it's all evolving really, really fast. And I think Adafruit has a lot of hardware that can help do this kind of thing. So I'm really looking forward to seeing how it all goes.
Cool. And yeah, folks, check out Anne's playground. I think you published him today. So
yes, I did.
So, if you're interested,
Adafruit-playground.com.
That's it. Cool. All right, Anne. Well, thank you so much for coming by.
Thanks a lot.
Bye. All right. Next up, we're going to check in with Tim. Hello, Tim.
Hey. So I have been working on I2SN for CircuitPython. So for folks that don't know, we had support in CircuitPython for PDM microphones, but they're not quite as good. And there are some devices like the Sparkle Motion, which have a built-in I2S microphone. And we did not used to have support for it. We had I2S out, but not I2SN. So I've been working on I2SN, and I have a demo running here with sound reactive NeoPixel setup. So this one is running on a Feather RP2350. The same thing can work on an RP2040, and it also works on ESpressif devices as well. There's a PR in the CircuitPython repo if anyone wants to try this out. Otherwise, it will eventually make its way into the CircuitPython builds. And one of the really cool things that we were able to do was use ULab with FFT to split up the audio into different frequencies so that we can run not just reactive based on the sound, but also reactive based on different frequencies within the sound. So we got like, you know, bass and middle and high notes as well, so they can split up. So you can see it reacts to me as I talk. If I tap, then it comes through really good. And then I have loaded up the Ion NPI song because I figured that was safe to run on YouTube. So I'll start that up and I'll shut up and we can watch it run for a second. But I like this this bass section is cool that it picks up as well.
Yeah, you could hear when you can see the separation between like the kick drum and the hi-hat. That's cool.
Yeah, totally.
That's so cool.
So yeah, audio reactive, that was one of the main things I want to do, especially for like the sparkle motions. So those pins will be enabled once we get this merged in. You'll be able to do the microphone on those devices. Nice. And then the other thing, which is not hooked up in this demo, but you can see it kind of hiding in the background there, is SD cards. So you can record to WAV files as well. So if you want to record little clips, save them to the file, or possibly, I haven't tried it out, but I'm thinking maybe something like those walkie-talkies that we got the guide for recently would be cool to be able to do in CircuitPython as well. So
that is so cool.
Yeah, thanks. That's what I've been up to. Like I said, PR is out there. If anyone wants to try it out, I'm definitely open to feedback on that.
Cool. All right, folks, check it out. It is there's a PR out there for it. Cool. All right. Thanks, Tim.
Yeah, for sure. Thanks.
All right. Bye. All right. Now we're going to check in with folks from the community. We got Cooper, Relic SC. Hello, hello.
Hey, Noe. How are you doing today?
Good.
Thanks for letting me on the show.
Yeah,
yes, we are geared up. So I think I've actually shown this off a while ago, but I stopped development on it about a year ago because I ran into issues with it. And I recently came back to it and fixed out a lot of those bugs, and it actually works now. So I'm really happy. What I have here is it's a little RP2040 based board. It has a 0 on there. It's in progress. I need to revise it, but it's running Arduino and has a guitar op amp as well as a codec and a bunch of other stuff. And I wrote a whole library for handling different effects and managing the UI and everything. So basically what I've developed here is it has about 20 or so effects available, and you can just reprogram it as you need it, as you want it. And it's a little multi-effects guitar pedal running on an Arduino. I'd love for it to be on CircuitPython, but we have development with that. What Tim was talking about there, this actually ties in really well to that. So hopefully that's something we can have in the future.
Yeah.
Anyway, right now I have just a reverb demo running. So this is clean. Can you hear that, by the way?
Yeah, it sounds
okay.
Good.
And then this is reverb.
Oh, yeah.
I can add more, make it crazy. This is actually using Freeverb. So a lot of these effects were actually, based on the work done in CircuitPython. Some of them, like I have a phaser and some stuff like that, that I actually kind of rolled into CircuitPython later on that originally came from this Arduino library. Anyway, so
it's so cool. What were those effects? It's a little bit more than a reverb, right? I'm hearing a little bit of like a detune or something else.
No, it can do that. And that's one thing. All the effects I put on there are all like basic, but the way it's structured is you can combine things together. Like for instance, I have recently a friend of mine wanted to do like a guitar bass thing where they like split the signal out. And this is getting nerdy music stuff here, which I'm sure you'll enjoy. And it was difficult because it's like, oh, you need like 3 different pedals to make that work. And what I ended up doing is taking this and first putting the signal through an EQ. To get out a lot of the high end, focus on the lower notes, so it just filtered it out. And then I sent it through a pitch shift. And I think that's all I did. I think I added a noise gate as well. And all that could just be programmed in to run on a sample by sample basis.
Oh, okay.
So
sweet.
It's kind of the beauty of it. It's always been kind of my dream to have like, oh, here's the pedal you can program, right? And it's simple, just works. So anyway, that's all I really got for you. So I'm going to share the link, the URL,
please,
to my little website that features this, that talks about all the effects and everything. And if anyone's interested in checking it out, I would appreciate that.
Cool. Yeah, there it is. It's on the Discord, folks. Check it out.
I mean, I can play. Yeah, it's maxed out right now.
So. Yeah, like maxing reverb right now.
Definitely.
Oh, that's cool. All right, Cooper. Well, thank you so much for sharing that, and love seeing your progress. And come by next week if you want.
I'd love that.
All right, Cooper. Have a good one.
Bye.
All right, bye. Wait. I'm here. Okay. Let's say we have 10 minutes. So, special guest, would you like to come on?
Sure.
Special guest is here. They're the one who gave me the note. Thank you very much, special guest.
I would like to clarify that you requested the Post-it. I wasn't being a jerk.
Yeah, thank you. I kind of don't know how to start these, but thank you.
That's all good. That's why I have a Post-it every week that tells me what to say.
Yeah.
And I just dropped what I was going to share.
Did you really?
I really did. It went like deep under your desk.
Okay, well, we'll work with
it's
just
okay.
Yeah.
So I've been working on there's an IKEA matter sensor called the IKEA ALPSTUGA, and this is the PCB for it. But I took it apart. This is the front for it. And I was originally wanted to run CircuitPython on it. I've done a couple of projects like that this year. The Yodo Mini I attacked, and then I attacked the XTE X4. So I thought this could be my next target. But it uses a Scilabs chip that is actually completely locked down, which means you can't even erase the flash, which was very sad. So then we thought, well, we'll just make our own PCB. They'll then be able to run CircuitPython. So I've been doing up a schematic with an ESP32S3, LED driver that uses LEDs, all these little things are LEDs there, and that's the display, all that. However, the only thing is it obviously has to fit into the enclosure. And
I'm sure it's down here.
It is down there.
Let me wheel out of here.
You're gonna wheel out?
Yeah.
It's right there.
Okay, so this is a really cool technique for reverse engineering.
So I took a photo of the PCB and I made sure it was straight and everything. And then I brought it in as a canvas to Fusion 360. And then Fusion lets you calibrate canvases. So you can, if you know for example, the length of the circuit board, you can set 2 points for either side, and then you can say it's this distance, and then it will size up the canvas, so then it's to scale in Fusion. So then I was able to do that and draw the outline of the board and get the mounting holes, and also there's a little kind of cutout here for a light sensor. So then I was able to print that and fit it onto the front plate, which has all these cutouts for the LEDs and the mounting holes to make sure I was on the right track for scale and everything before I do too much work. And if I flip it to the right side, it does fit, everything's lined up. So that means next I can map out all the coordinates for all these little LEDs, and then I'll be able to print that too, so that I can make sure they're all fitting into this grid here that helps to diffuse the LEDs so that you see the numbers on the front. And once I have that all set, then I can do the actual PCB layout. So that's what I've been working on with this.
Sweet. That's a great tip. I've seen folks do something similar with like printing their layout on paper, but this is a little bit more rigid.
Yeah.
And you can actually test it mechanically.
Yeah. I used to do the paper technique, but ever since I realized you can actually 3D print it, and then you can actually make sure it fits in and everything. Because another thing we're working on, you wanted to use these kind of hollow rotary knobs.
Yeah, they're called ring type rotary encoders.
Ring top rotary encoders.
Yeah, they're normally used in like car stereos and stuff. Yeah, they're really big and they allow you to fit things into it, like another button or something. So
yeah, and so I made this PCB that we're working on to kind of prototype with it, and it needed a custom footprint. I was using KiCad for the first time, so I actually printed out the footprint so that I could size it up, make sure I was on the right track, because otherwise it's scary to just send that off to the PCB fab without any context.
Yeah, here's what they look like outside of the PCB. They're just like this little round thing, and this spins here. Pretty much like a normal rotary encoder, 3 pins.
And then you printed, and it works with CircuitPython too. And then you printed this nice ring on the outside, and then inside we've got an MX key that can be pressed. So that's another thing we're working on. And with that, I also use the 3D printing technique. So I highly recommend that.
Yeah, definitely.
For sizing up your PCBs.
Cool. All right. Well, thank you so much, special guest.
Thanks for having me.
There you go. All right. That's going to do it for the show and tell. Thank you everybody so much for coming by, and have a good night. Bye, everybody.